Hello, my name is Marky, and this is my second SDP project. So I just wanted to change things up a little bit and create a video instead of standing in front of the class and presenting. To begin, there are 4 stages of
Levels of structure.
These 4
Levels of structure.
make up the proteins that our body uses to grow. The process starts in the ribosomes, the protein factories of the cell, located in the cytoplasm of the mitochondria. The first level of structure, or the primary structure of the protein building process, is putting amino acids together. To put them together correctly requires a blueprint from the DNA. When that code has been read by the ribosomes and the chain is completed, that simple chain is built and it is called a polypeptide. This first stage is like, if you compare it to a group of people, it is like that group of people just standing in a field and not knowing what to do. Okay, so let's get started on the secondary structure. So the secondary structure is basically just the amino acid chain's interactions with itself. These interactions are determined by a thing called backbone interactions, as well as their hydrogen bonds. For instance, some amino acids are hydrophobic and some are hydrophilic. The amino acids that are alike in that way attract one another and start to fold the amino acid chain together. There are 2 primary patterns that form when this kind of folding is happening. One is called the alpha helix, and the other one is called a beta sheet. This would be like the people that I just mentioned, all starting to learn a new craft, like becoming a farmer or a blacksmith, something very basic, and just starting to develop their own form or town. The next level of structure is called the tertiary level. This refers to a higher order of folding within the polypeptide chain. This is as complicated as one polypeptide chain can get. These folds can depend on a number of forces, such as van der Waals forces and disulfide bridge formations. Van der Waals forces are weak short-range, electrostatic, attractive, and non-attractive forces between uncharged molecules. And a disulfide bridge formation is the gap closer between 2 parts of the same molecule. The pH, temperature, and salt balance all have to be just right for this complex folding to occur. Under a microscope, though, these structures might look random, but they are anything but that. They were carefully encoded into the DNA before the molecule was even created. Okay, so now imagine that the same people that were just farming and forging crude weapons have created a town with a complex system of government, a police force, and a school system. That's basically what just happened between these 2 structures. Okay, so now we have finally reached the 4th and final structure. The quaternary structure is the bonding between multiple polypeptides. This is the biggest kind of protein. The tertiary structure could be used as a protein, but this is the way most proteins are meant to be built. Most of the same forces that bond acid chains together are responsible for bringing multiple polypeptides into one big molecule in the same area. When the 4 or 5 polypeptides merge, each polypeptide is now categorized as a subunit. Now imagine that the people who picked up some basic tools a while ago are now lawyers, doctors, stay-at-home moms, programmers, and other specialized workers, because the conditions let them do so. Okay, thank you guys so much for listening. This has been my video presentation, and Mr. Mimio, give me an A. Thank you.